Folks, hello and welcome to your Week 8 discussion post. I believe this is the last major discussion post since next week you will be in your final exam study hall. So this is the last of these, what have been, I think, a fairly rigorous portfolio of discussion posts from beginning to end, from week 1 up through now in week 8. And I think I mentioned last week on the board that as this course has been redeveloped, the course developer, which was not me, it was one of the full-time faculty, I think she did a really nice job putting together what I called it was kind of a portfolio of discussion posts that leverage everything we did in week 1, where we looked at functions and we looked at horizontal and vertical asymptotes and limits, left and right limits, and continuity, and that's obviously where differential calculus begins. And then we're going to play that all the way through to week 8 here, where we're going to look at the definite integral, where you have integration bounds, not just simply looking for an antiderivative, but looking at definite integrals where you have integration bounds, lower and upper bounds, and really a neat application to close out this discussion based on the scenarios we all kind of came up with last week based on our function from week 1. So this is a nice little discussion post. I will tell you the Desmos work this week is quite intensive. So please pay attention as I'm going through my explanation of what I have in here. There's a lot of really neat things in here this week, which I think is good for you all, especially if you want to use this tool going down the road. So without further ado, I've got the discussion post description pulled up here, and it basically says, what we're going to do is we're going to look at the antiderivative, I should say the first derivative from last week, and the antiderivative, obviously, which was the base function, one of your base functions from week 1. And we're going to look at some relationships between those two over certain intervals, and Desmos is going to help us out. So that, that discussion is wrapped up here between the post and reply and explore and interpret. And as you read through this and this discussion here about the A's and the B's and infinity, that will all relate to the integration bounds that we're going to talk about here in just a moment. And so let me pull up my function. Notice I do have there's a lot of Desmos. So obviously this will be available to you, and I will make sure that I go slow through this to make sure that I explain. Obviously, you're going to have to retype this, but this number of steps should get you to the goal line on this problem. And I think, again, it's a really good one to kind of finish this out, so that let me actually get that out for a second, so that you all again have a kind of an appreciation for this from beginning to end, where we started on the differential piece. So again, without further ado, let's see. G of x, which I show as the current graph, is the derivative of my base function that I had from, let's see, a couple weeks ago, and I'll explain that. Actually, let me pull that back up. So this was the base function. So if this is the derivative, the antiderivative of the derivative takes me back to my original function. And the integration constant that I have here is 9.06. That was the integration constant that I needed to increase the maximum from whatever it was to, let's see, twice that amount. So that's what I'm showing being graphed here. And remember what I said, because the scenario is important here. Remember I said this represents some golf manufacturer, and at the start, and really this base function that I show here is describing what is happening to sales when this really great golfer tees off. So I don't know if maybe you're Scotty Scheffler or John Rahm or Rory McIlroy fan. If you're a golfer, let's say for the heck of it, it's Rory McIlroy, and I think he plays TaylorMade clubs. So before Rory gets ready to tee off at some major event, The company has sold about, let's see, 9,000 sets or 900, it doesn't matter, some number of sets of clubs. And then Rory tees off, and obviously there's, there's some increase here, and about 0.6 hours. Remember, I'm measuring the horizontal axis in hours. About 0.6, so 6 times 60, about 36 minutes in, Rory does some bad things. So that's where this story takes off. And the integrals that we're going to compute here, these definite integrals especially, are going to tell a little bit of the story. So let me, so what I have shown again at first here is the derivative. This is the derivative. The antiderivative, again, is just the integral of the derivative, which takes us backwards. We've talked about that kind of that inverse relationship, almost like addition and subtraction, so on and so forth. So let me not belay this anymore. So again, I show one more time the base function and its derivative. And now, so I'm going to integrate here. Let me, before I go any further, notice this, these first two lines, line 2, 3, and 4. This is sort of some preamble to set the stage. In order for all my Desmos to work, notice that I have started a folder at this point, and you will have to start a folder so that all of these sliders, and we're going to do some shading to talk about area here, to reinforce area. And so make sure that you start a new folder when you get here. And for each of the integrals, it talks about 3 integrals, and this is my first integral. So let's see, notice that I have a folder here. So when I expand it, I have all the goodies that go along with it. So the first integral, again, is just in the definite integral from 0 to B1. B1 at 0.639 hours is the peak. And so what I'm going to do here, let me start turning some things on. I didn't want to do that. Let's see, let's get this back to 0. Apologize for that. So let me get this back to 0. And let's see, what I actually wanted to turn on was this little piece right here. And what I have is what I'm interested in this first integral is what's happening here. I've got, again, the base function, and what really is of interest here is the derivative, which that first derivative is the rate of change of sales of clubs, right? So we're talking about base function, number sold, and the first derivative is just the rate of change of clubs, which is happening really, really fast when Rory's doing well, and then all of a sudden when Rory hits one out of bounds or whatever, things start going bad for the manufacturer, as we might expect. So let me turn on a couple more pieces. So what this syntax does right here, this syntax is going to show me the area under this curve, which is the area under the rate of change. And if you look at the value of the integral itself, so when I'm integrating this function from 0 to 6.39, and again, that's time, the total area under the curve, or the total volume of clubs sold, is about 11,000. But you have to remember that Title or TaylorMade, I think he's a TaylorMade guy, TaylorMade started out with about 9,000 already sold. So if I look at the difference between 11,450 sets of clubs sold in that first 36 minutes after Rory tees off, and I subtract it from 9.06, that difference, which looks like about 2,000, I mean, maybe about 2,400, is represented by this area under the curve. Again, this being the rate of change, and the rate of change over time, and that area represents this difference, again, the total number being sold minus what TaylorMade had already sold in that day. And let me just take a second to say this. Remember, area under the curve here is what the integral represents. And if you look at just one of these squares, this is, let's see, this is 1 hour. So this is 30 minutes. So basically a half an hour times, let's see, 500 clubs sold. So if you take the area of each one of these curves, so or I should say squares, so about 0.5 times 0.5 is about 0.25. And if I add up all of these, you notice I don't have completely all of this square under the curve, but I do have a little extra here. So if I take this little sliver of area and I replace it up here, if I take 0.25, let's see, 0.25 times 2, 0.25 times 2 is the first 1,000 sets of clubs, which represents this difference. And then if you look at this area, well, again, where, and then you take some of this and you kind of throw it down here. Well, there's the second 1,000, and then the other 400 sets of clubs is right in about here. So that's what this area is representing, again, being the difference between the total number of clubs being sold and those that had already been sold before Rory teed off. So rate of change in the area under the rate of change curve, or the area under the derivative curve, is telling us the total number of clubs sold in this amount of time. So again, neat application. Let me move on here and just, let's see, let me just turn on the rest of this. I think you're going to get the story here real quick. What I did is I chose the second integral was from the peak to 1 hour. And from the peak to 1 hour, obviously, things are, the instantaneous sales here, not so good. And if we look now at this area, notice first of all, let me blow this up a little bit. Notice first of all, the area from the point where Rory hits the ball out of bounds through that first hour, the area that we're looking at is below the curve. And what does that mean? It means that the sales have decreased off the peak, right? The peak, excuse me, at the peak, things were really good. The area is above the curve. That's saying that, the rate of increase has been positive. What we're saying now is, since Rory hit a ball out of bounds, it looks like, let's see, we're down about 730 sets of clubs in that hour. So that's not a good thing for the manufacturer. And then, let's see, I've got all that turned on. And then the final piece of this is when I integrate from time 0 to infinity, what effectively am I saying? And let me turn on all of this. This is going to be an ordered pair that you're going to see labeled on my graph. And then let me fill in these last two pieces. And if I go up and I look here, when I integrate from 0 to infinity, what I'm saying is in the course of a full day, how many sets of clubs do I expect TaylorMade is going to sell? Excuse me, I got a scratchy throat here because of some allergies. I apologize for that. And it looks like over the long term, about 9,000 sets a day. And again, the thing that we would take away is that, number one, Rory McIlroy is not on TV every day. And things are good when Rory's good, but when Rory's not doing too well, notice that we would certainly expect some decline. But over time, I would just consider infinity to be in the course of a day. Over the long term, we would expect to sell about 9,000 sets of clubs per day. Let me just show you here that this third integral, integrating from 0 to infinity, and again, plus the integration constant or the antiderivative evaluated at 0, which in our case is about 9,000 sets of clubs. This I3 453 over 50 is about 9.06. Just so happens this syntax right here is just a way for me to label this point. So this is an ordered pair. The minus 0.2 just kind of pulls it down off the line. And again, this is just doing some shading for you. So a really robust post to get us finished up on this. And I hope you enjoy it. And I'll look forward to seeing your work on the board. Thanks and take care and have a great week.